Hello and welcome back. Today we are going to be beginning a new unit, which is Unit 5 of the Grade 11 Functions series. All right, so here is the homework sheet for this unit of the suggested practice problems from the Nelson textbook, which is linked in the description if you do not have a copy of said textbook. For today, we are going to be learning about arithmetic sequences. Next day, we're actually going to combine 1 and 2 together and learn all about arithmetic sequences today. It's not that large a topic. There's only so much to know about arithmetic sequences. Then we'll talk about arithmetic series next day. Then we'll talk about geometric sequences, then geometric series. So there's really only 4 topics in this unit. This unit, the main advantage is that it's a very straightforward, simple unit. Unless you're being asked proof questions or you're taking like an AP or IB course, there's really only so many questions your teacher can ask you. You know, it's always going to be some version of really the same thing. So that's the nice thing. The disadvantage is this, in my opinion, is probably one of the least intuitive forms of mathematics, where a lot of the times you can kind of imply and infer whether or not you got the right answer from certain factors. But here it's very hard to do that, especially with the geometric series when we're adding up those, which we'll go over why that is later on when we get there. But it's very unintuitive. You can get some sort of crazy answer, and yet it's actually the right answer. And so it's that's the tougher thing about it, is it's hard to know if you're right or wrong just by kind of trying to gauge and give a guesstimate. You can't really do that here, or at least if you can, fantastic. But I've never been able to figure out how to do that, and it seems very like a very unintuitive topic for a lot of folks. Okay, well, with that said, let's talk about our series, or our subject today, which is the arithmetic series, part 1 and 2. So, an arithmetic sequence. An arithmetic sequence is a list of numbers in which consecutive numbers are separated by adding or subtracting a number. So, for example, 1, 2, 3, 4, 5 is an arithmetic sequence because each time we just add 1, right? Plus 1, plus 1, plus 1, plus 1. Same with 5, 4, 3, 2, 1, etc., right? Because each time all we do is we subtract 1, subtract 1, subtract 1, subtract 1, subtract 1. Now, it doesn't just have to be 1 that we add or subtract, it can be other numbers as well. So, for example, 3, 5, 7, 9, etc. would also be 1 because we're adding 2 each time. Same with 0.5, 1, 1.5, 2, etc., right? We're adding a half, right? We're able to add fractions and decimals as well. We're able to subtract fractions and decimals. So, for example, 9, 7.5, 6, 4.5, etc. This would be 1 because we're subtracting 1.5 every time, and so on. So, as long as we are adding or subtracting the same thing over and over and over again, that's all there is to it. The main elements that you need to know about the arithmetic sequence are that we have the first term. They have to start from somewhere. The first term could really be anything we want. And then we have to have the common difference, right? The common difference. And the common difference is just the number that we're adding or subtracting each time. Well, actually, I should just say adding, because if we are adding a negative number, then the common difference will be negative. So we wouldn't say, oh, we're subtracting 1, so the common difference is 1. No, we'd say the common difference here is negative 1, right? Whereas here we would say common difference is positive 1 because we're adding 1 each time. So we use negative in our common difference to indicate that the number is being subtracted, and plus to indicate that the number is being added each time. So that's basically that. Those are some examples of some arithmetic sequences. There's also a formula sheet somewhere with the different formulas. I don't see it, but that is okay. I'm going to write down some important formulas that we're going to need to know very shortly about this. So here's an example. This one says find the 30th term, or T30, of the following sequence. Now, there are 2 ways to do this. And probably the way that came to mind for most people right now is to say, oh, well, this is term 1, 2, 3, 4. So if we just keep going and we realize the common difference is 7, then we can just keep going and writing the numbers out. So we can say, okay, well, what's term 5? Well, what's 16 plus 7? Oh, well, that's 23. Okay, so that's term 5. Great. Okay, what about term 6? Well, let's add 7 again. What's 23 plus 7? Oh, it's 30. So voila, there it is. And then we just keep going until we get to the 30th term, right? So that is one way to do it. And I will admit that that will work. However, what if we're asked for the 500th term, for example? Are we really going to do this adding thing 500 times? Probably not. That's probably going to take forever. And even the 30 terms, I'm not going to go through past 6 because, it's just going to take too long to do that. So I'm going to show you guys a different method for how we can quickly and easily find the 30th term, because the question didn't ask us to list out all the terms from the first term to the 30th term. The question only asked us specifically about the 30th term, so we really don't care about the other terms. Now, we would have to do it this way if the question asked us to actually list out all the terms, but notice that it didn't do that. It only asked for the 30th term, and there's a reason for it. So that I'm going to get to in just a minute here. Okay, so the formula to find the nth term of an arithmetic sequence is a, or we'll say tn, so whatever the nth term is that we're looking for, is going to be equal to the first term, so t1 is what we'll call the first term, plus n minus 1 times d. And I'm going to define these terms. So t of n is the nth term in the sequence. Okay. Now t1, therefore, well, if tn is the nth term in the sequence, then t1 would be the first term in the sequence. And that's something we know, right? We can see the first term, the very first number here is -5. So that's something we know, right? We already know that. Okay. What about n? N is the n in this case would be 30, right? N is the number of terms that we are counting, right? So the number of terms, here they want the 30th term, so n is 30. And then let's see, d is the common difference, which we talked about earlier, is basically the number that we continually add and subtract, right? What do we have to add and subtract to find one number to the next, basically? So let's do that. Let's plug that in. So t of 30 is equal to t1, which is -5, plus n minus 1, which is 29, times the common difference, which is 7. So that's going to be 29 times 7 minus 5, which is 198. So therefore, 198 is the 30th term in the sequence. Now, I want to talk a little bit more about this formula because I encourage you to really understand this formula and not just memorize it. Now, that said, for grade 11 math, you can memorize it and you will do just fine on your test. However, it is always good to understand where this formula comes from. So if we think about it, what are we doing each time that we go up a term, right? From one term to the next, we're adding that common difference. So let's say we add that common difference, let's say we go up to term 5. Well, we're taking the first term and we're adding that common difference 4 times, and then we end up at that term. And that's exactly what we're doing here. We're saying, let's take the first term and then take how many terms we're looking for, -1. And the reason that -1 is because that, if we're going from term 1 to term 5, right? From term 1 to term 5, we're only going up 4 times. So that's 1 less than 5, right? Or let's say we're going up by 3, right? We're going from term 1 to term 3. Well, there's only actually 2 steps, right? We start with term 1, then we add the difference once for term 2, and then a second time for term 3. right? So we only added the difference twice for 3 terms. So we always add we always add the difference one less time than the term number, right? For that reason. So that's why it's n minus 1 instead of just m times d. So basically, this is a shortcut to say, well, if we're just adding a number, because I mean, we probably learned this at elementary school, that if we add the same number a whole bunch of times, that's the same as multiplication, right? You probably learned back in primary school that if we take the number 10, for example, and we add 10 plus 10 plus 10 plus 10, we add 10 7 times, that's the same as 10 times 7, right? And so it's the same idea here, just written in equation form and used specifically for this sequences. Basically, we start with this term, and then we take however many number of steps, right? We multiply that common difference by the number of times we're actually going to go up by that common difference or go down by that common difference. And so that's where this formula comes from. And I hope that helps you guys not just memorize the formula, but really understand, well, how come this works? How come this is the true formula? Why isn't it some other strange thing, right? Okay, so what we're going to do now is we are going to find the arithmetic sequence is given here, and we would like to know the 40th term and then also the general term. So I haven't actually talked about what the general term means just yet. I will do that soon, but first we're going to try A for the 40th term. Now, I suggest, if you feel comfortable doing so, to give this a try on your own, pause this video, and then come back when you're ready to continue. Okay, so the arithmetic sequence, let's see, is 56 or 65 would be term 1. And the common difference, well, let's see, we go from 65 down to 61. So that's a difference of -4. And we know that the difference is always going to be -4 because it's an arithmetic series, right? Or an arithmetic sequence, right? And so it always has the same common difference. It's not going to change on us, which is good. And then we are looking for T40. We would like to know what T40 is. And so therefore, in this situation, n is 40 because we're looking for the 40th term. Now, again, n can really be anything we want it to be. But in this case, we're being asked about T of 40, the 40th term. So n must be 40. Okay, so let's solve it. T40 is equal to T1, 65, plus 40 minus 1 times the common difference, which is -4. I'm just putting that in brackets so that it's clear that it's times -4 rather than we find 40 minus 1 and then subtract 4, because without those brackets, that's what it would look like. Okay. So let's do that. 40 minus 1 is 39 times -4 is -156. So we're going to have 65 subtract 156, which is -91. So therefore, the 40th term is -91. And voila, we did it. All right, well, in the next video, we'll pick this up, and we're also going to learn in the next video the general term, okay? So that's going to be in the next one, and I will see everybody then. Bye.